Hello from my side and welcome to this session on how to write tests that spark flow. I'm very happy to be here at EclipseCon. Now this time it's online. I just remember it seems like yesterday that we've all met in Germany at the EclipseCon in person last year, but now due to these times we do it this way. And I'm about to share my screen because we're gonna see a lot of, well, live demos and live coding. And I hope you're all doing fine wherever you are. And now let's do some fun topic on, well, the topic of testing. So write tests that spark flow. My name is Sebastian. I work for this company called IBM, and I do a lot of things for Java and enterprise Java in general, for Jakarta, and, well, also on testing, because I think that's an interesting topic. And another fun fact about myself, I like coffee. So actually, I'm going to show you some coffee shop example application. And a very important takeaway already is here that we're going to show some example that's a little bit more than just a trivial Hello World example, where we actually have some communication in our Jakarta or enterprise Java microservices and some persistence. So imagine we had a coffee shop with some persistence here involved with a database where the users can go and order some coffee, and where also we have some communication with another backend, another microservice, Barista, that friendly barista person who brews our coffee. And just to be a little bit more interesting and more complicated, if you want, we're going to make that communication asynchronous because we need to test that. All right, so without further theory, let's show some code here, and let's have a little bit of an example. So what I will show you today is a Quarkus application. You probably have heard of this Quarkus technology, supersonic subatomic Java, that is built upon enterprise Java technologies and also Jakarta and microprofile APIs. So we're going to use this because of the, well, developer experience that we get out of it. It's somewhat beneficial. It, I think, makes sense. And I'm going to show you how to efficiently test this. So first of all, what I have, this is this coffee shop application. This is our main application that we care about. And this is built on Quarkus. So, you know, you see some Quarkus dependencies here. And just to quickly go through the, well, main code that I want to show you, we're basically communicating via HTTP, via REST, and we're creating some coffee orders. So we're going to talk a lot about these orders. So we, you know, can list some orders, we can create some coffee orders, and so on and so forth. And it basically means we have some JSON responses here, and we can use this method, for example, to create some coffee order. And then, well, it will just be persisted. Okay. So far, so easy. And then in the asynchronous way, we will later on see that actually the status of our coffee orders will be updated. But now let me just quickly build and run this locally, because what I want to show you at first is a way how to do basically a system test or acceptance test, how you want to call them, basically testing the application, how it would run in a very production-like way, but in this case, locally. So locally on my computer, I actually will just run an environment. And in this case, I will run Docker containers, actually 3 of them. Why 3? Well, 1 container for my application, for the backend, and also for the database. So I can test that locally, and I will show you on the command line basically how that works. So I have 3 Docker containers, coffee shop, Barista, and the database. And then once that is up and running, I can go to localhost 8001, for example, check the health check. If you know about microprofile health, then you assume correctly that this is actually included here. So now we see, okay, it's up and running. That's great. So we can see the orders in the system. And of course, the system is empty. So there are no orders here yet. So we're going to change that by creating some coffee order. And this is now manually a scenario that later on, of course, we want to test in a little bit more, well, sophisticated way. So basically, we're going to, through a similar example like this, just please create some order and then see what happens. So I do something like post some JSON. So post, I use curl here on this in this way, but doesn't matter, whatever speaks HTTP, right? So I'm going to post some JSON here, which in my case is just a type. So actually we had a look what we want to build here. An order ultimately has an order type. This is like an enum, you know, whatever order you want, whatever you want to order, like an espresso or latte and things like that. And an origin, which is actually a country. So let's say we want to have an espresso, and let's say we would like to have some coffee. I like coffee from Colombia, for example. So let's order an espresso from Colombia. And then if we're lucky, yes, it worked. HTTP 201 created. So now that order is in the system. And if it's in the system, okay, I can actually see it. If I query that resource again, then now it looks good. I have that order in the system. And now if I were fast enough, so let's do this again, I see actually that I have different statuses here. Now I have just quickly ordered a second coffee, which now was, well, first preparing, we didn't even see that, then it's finished, and now it's collected. So asynchronously, we have this communication going on between our application and the backend. All right, now you saw, well, everything works, right? So ready for production. I just tested my application, well, manually, right? But of course, as we know, that is probably not the best way. So we would like to have some automated tests. And in my case, I start with some system tests similar to what I just did on the command line. So for example, I want to see, does my application work correctly from the outside, quote unquote, by using the external boundaries and going to these APIs that the user would use? And does it, well, behave correctly? Like, does it do the persistence correctly? Does it do the communication with the external backend, and so on and so forth? And now I have actually a second project, Coffee Shop ST, which is called System Test. There's a reason why I separate this into a separate project. Well, most of all because I want to be sure that we don't tangle the technology. It really needs to test the application from the outside. And what I have here, that is just called naive test, create order naive test. Why naive? Well, because I will show you in a second that this is a way how I often see testing in enterprise projects, but probably not the best way. So what is this? This is a JUnit 5 test that uses an HTTP client. In my case, that's also actually Java E/Jakarta technology. So this is JAX-RS for the JAX-RS client to connect with my backend, with my application. All right. What does it do? It builds this URI, localhost, and so on and so forth. And then I want to create and verify an order. I want to see whether this works correctly, right? So we can briefly read through this. I will create a new order object like Espresso Colombia. Then, of course, I need to create that JSON that we had, and so on and so forth. I use this technology to just send it to my target by posting this to that URL. And then, of course, I want to see that it was successful, HTTP status. And then I know, well, the URI is being sent back from that location. So I can actually then go to that URI and check the order, whether it, well, is equal to whatever I created in the first place. So in other words, whether it's persisted correctly. And then we can also list all of the orders and see whether it's contained and so on and so forth. And you see, well, this is actually a bad idea. So there's a high chance that you have seen tests similar to that one, but first of all, it's not readable. I mean, you know, I just read it to you what it basically does. But if you see this for the first time, you really need to get into it and, you know, fight your way through all of these details to actually understand, well, what happens here? What's the point? What are we actually testing? And the problem with these tests is that it actually, well, has too many concerns. Or in other words, it has too many layers of abstraction. And this is already one of the most important takeaway, this abstraction, that we actually craft proper abstractions, not only in production code, but also in test code. And this is really, really important to keep maintainable tests and comprehensible tests. So for example, let me do this again. Test, create verify order, something like this. Just another method where I now want to pseudocode something that shows us how to do this in a little bit more, well, efficient way. So first of all, and I deliberately do this in code comments or sometimes even on paper, I want to see what do I want to test here. Well, what did I want to test on the command line? I basically want to say, well, something like create a coffee order with espresso from Colombia. That's it. That's the end of the story. That's what I want to test from a user perspective, from a high-level perspective, how I want to craft my test. Well, and then actually afterwards, I want not only Colombia, I want also to verify that order, well, has this data, has espresso from Colombia. And order, I need to identify it somehow. So order with, let's say, call this order ID. So I need to save it here in the first place, how this order was created. And this is basically the contents of my test. That on an abstract level is basically what I want to test, how my system test here needs to look like. And this is really, really important that we just take care that we have proper abstraction. So you see, this is really, first of all, not readable, and it's also not maintainable. Well, what does it mean, not maintainable? Well, easy. Just imagine what would happen if you have this code and then tomorrow you have another functionality, not just espresso, but maybe a cappuccino as well. So then, of course, what happens, you take all of this code and, copy paste it, and then you just change espresso to cappuccino, and then there you go. And if you repeat this a few times, then you have hundreds of lines of code of just unreadable and incomprehensible test code. And this doesn't get you far, especially for a complex project. So this is really an important takeaway, that for a complex project, this needs to be taken into account. So let me show you a different code example. Create order test, now without the naive. And now what did I do? I included abstraction and delegation. So I'm delegating the lower abstraction layer to, well, a delegate. And to be honest, this is, nothing new. We do this in production code all the time, but I can tell you it's also allowed, and it's a good idea to do this in test code as well. So coffee order system is basically a delegate for all things coffee orders, right? And we say create verify order. This is now the same test that we had before. And if you now compare it with the pseudocode that I created, well, it's the same in Java code, right? New order espresso Colombia, and then coffee order system create order. How it is being created, I don't know, I don't care. That's a different layer of abstraction. Then order URI, this is a URI, so an identifier in this case. And then later on, I tell my system, well, please get the information from the order again. So load that order from the system and, of course, compare it, whether it has the expected type and origin. And bonus points if you get the list of all the orders to see whether it contains my URI. All right. So this is basically the same thing that we would like to test, but now it's really readable and it's maintainable because it's just a few lines of code. And if I change one item, well, then it's visible. I see it immediately that there's a difference in cappuccino, for example. And well, this now is the Delegate coffee order system that I just created. And also, important, what if my communication changes, right? So what if I would swap HTTP for something else, or swap JSON for something else? Well, if I had that test here, then, I'm basically screwed, right? Because I'm mixing all of these aspects like JSON, and here's some HTTP, and there is, some more HTTP and things like that. And I'm not properly abstracting the details in the same way like I do it here. All right. So I could go and run this example already, but I want to show you a little bit a more sophisticated example using a system test that also involves the Barista, our second application. Why? Because, well, the Barista is an external system, which we also need to take into account, and we want to see whether this arrow, whether this communication also works as expected, like whether our coffee shop behaves as expected. So we want to see whether the status transition of the coffee orders works properly with the Barista. And we can, as you can see here, include a mock. We don't have to run the actual Barista. We can, that depends on your circumstances, but we can run also a Barista mock, like a mock server. I use Wiremark in my case, and then control that from the system test and see and verify, similar to Mockito on a code level, whether that works as expected. And what I do here, that's now the second method, as you can see, create a coffee order and please check for the status update. So not only create it and, similar thing that we had before, but now see, okay, I know or I assume that my application has the status update correctly. And then I actually tell the Barista system, because it's like a mock, it's like Mojito when. So please answer for the following order once you will get it, that you're now in preparing state, or later on that you're in finished state, and so on and so forth. So I'm basically telling it, well, do the status update, this ping pong, like please reply as appropriate, and later on reply in a different way. And at the same way, go back to the coffee order system and see whether it has been persisted. So in my test, I basically always go back and forth between the coffee shop application that I actually want to test and my barista, just tell them, hey, the next time you'll be called with this information, just respond accordingly. And now you see, well, the Barista system, I can show you, it's using Wiremark under the hood. And Wiremark is a technology that's basically, something like a mock server, an HTTP controllable server. And I can see, well, in this case, answer like this and that, or later see whether a request matched and whether you have been invoked with things like this. Actually, now you see that here we have to wait. Why? Well, because it's asynchronous, so we cannot be sure that a certain invocation has happened after we did our first call. We just have to wait until it actually happens, but with a timeout, because we assume that it happens after a while. And now what I do actually instead, so I stop my Docker containers again, and I start up a similar environment with just, well, where's the difference here? Now, instead of my Barista, I actually run a Wiremark. So good news, this works in Docker as well. It's actually very nice on that abstraction level of containers to swap it out. And then once that is up and running, I can actually start up my system test and just run it here. So I can do this, for example, here in my IDE. And let's first of all, once that is up and running, let's see here, and create and verify the single order. So I go against my first application, against my coffee shop, and then I just do the same thing that I did on a command line, basically say, well, please create a new order and verify it. I could do it again on the command line, and once my IDE woke up, then it will fire up the test. And this is already an important takeaway, that this type of test really runs fast. Well, once my, oh, there we go. Ratings to server, probably it's been started up right now. Let's try it again. Otherwise I will run it from the command line, but this actually should work. Yes. Now we see, once my IDE woke up, that it's now really fast to have this test. And I can see, well, actually 8001 orders. Now this should be in the system. Yes, that's correct. Now that order is also in the system. And in this case, why does it run really quickly? Because my test, and we will get back to this later, does not tangle the life cycle of my test suite. So this is really important why I only use plain JUnit. I want to be able to separate the life cycles from my test and my test environment. So this is why I actually use plain Docker to start up my application, because then it's not tangled together. Otherwise, I would need to wait for application startup. As you know, these Spring context tests or Quarkus test or a Killian test in the enterprise world, this is initially a good idea for a developer experience, but it's actually not the fastest way. So although Quarkus is actually, don't get me wrong, Quarkus is super fast in starting up, but if I need to wait, well, just a few seconds even for a startup, I don't want to wait a few seconds each and every time. So here, this test, this is now the second test, this actually takes longer. But why? Because, well, actually the business use case takes longer. So it is the nature of the asynchronous communication, which is a timer internally with 2 seconds. So it takes a few seconds each and every time. But now if I want to rerun the test and rerun the test, the rest is always very fast. And it just connects against the system that is already up and running. Another good news, what I can do, and I will show you this now in a second, is that I can do this now locally. And locally, I can also, thanks to this Quarkus technology, connect, well, what is called a development mode, which my Quarkus app comes with. And this also works with containers, like remotely, even if, well, remote only means locally here. And what that means is here, let's say this, let's see this way. This is the root resource that just includes some hypermedia links. So now I will change it, actually not on the test code, but on the production code. So this is build index. This is here, a big JSONP response. And I say, hello world. And then what it does, it quickly restarts my application. So this works in the remote mode as well. And I immediately have the changes here actually in my production code. And of course, good news, now I can go and rerun my tests as well. So this is actually what I mean with tests at Spark Flow. What you can do, you can actually come up with an environment and with a test suite where you always have, well, pretty much a very short turnaround time. So you don't have to wait. Either if you are changing production code, well, I just showed you hello world or hello EclipseCon. You can very quickly restart your app using this development mode of Quarkus, or you can just quickly restart your test I just showed you and restart it again and so on and so forth. And it always will run quickly, well, because of this environment that you set up. And this is really important for me because then I am in this flow experience. I don't have to wait because I don't want to wait. I just immediately get the feedback. And now what we can also do, and this is pretty cool, we can actually use these tests, since we separated them from the lifecycle perspective, and reuse them against another environment. So actually what I have for you as well is I have a Kubernetes environment. So what I do, I actually go and say, well, maybe for some reason I need to test my application on, a staging environment or a test environment that's running in the cloud or in a simulated environment where I have some extra backends that I don't have access to from my laptop. So, some things cannot be tested even locally in containers with this virtualization. But then in this case, I go against a Kubernetes cluster where I can also deploy this to and actually rerun the same tests. So I don't need to reinvent anything here. And how this works, well, I show you here. Basically, I have some Kubernetes clusters. I use a managed Kubernetes cluster that I'll show you in a second. So I use the IBM Cloud for managed Kubernetes access because, well, that's easier for me to set up. And I have the access here. So you can see, well, it's actually empty. I have an empty cluster here, accessed with kube control. So if you're familiar with Kubernetes, then this probably looks familiar to you. And what I now do, I just deploy this here on, well, in a system test way. And the system test type just, well, does a similar thing what I showed you via the containers. It deploys my coffee shop, but actually it deploys the Barista also with the Wiremark image. So this works. I can use this Wiremark image here as well. And then I can actually, let's see, once that is up and running, I can actually access my application via the IP address of my cluster. And for example, say, well, please give me the health check or give me the coffee orders. And then I can order some coffee in the cloud actually. So what I can do, I can just go to my system test. Now I do this on the command line and I can say, verify. And now instead of using localhost, I can point it against my cluster because I made that configurable in the test. You maybe saw it here in the, well, order test, coffee order system. I can swap this with some system property and then say, okay, please now just use my, staging URI or whatever you have. And I can rerun the very same tests against my cluster and now says, okay, now actually the system test scenario here in my cluster works as well, which is a very nice way because then I can just verify that here and I can show you that this works. I can ask for the orders again, and now we see actually there's something in the system that has been created by my system test. So we can go and take the same tests against a proper environment thanks to the separation here of the life cycles. And again, these tests run really, really fast. So this, enables a better efficiency on our side. All right, and now I just quickly want to show you some use cases for code level tests, because code level test is also always a little bit of a challenge, how to do code level tests in a somewhat efficient way, because for a few reasons, I just want to use a technology that just enables us to run our test fast, where I don't need to wait for a lot of reflection or anything. And at the same time, it can make a big difference how to set up our dependencies, not to tangle our tests and our production code too much. In other words, if I write some test code that is just tangled too much to my production code and then I refactor something, well, then once I refactor, I'm basically screwed. So, here I have an example with plain JUnit and Mockito, which, these tests run really fast because it's just plain JUnit. But as you can see, it's, well, also not readable. So I set up a lot of mocking and when, then, and whatever, and I don't even see what's happening. And if I change something, so this is my production class, the coffee shop here. If I change something here, if I refactor, then I need to adapt all of these tests, right? So what I do instead, and I explained this in my book, there I called it component tests, or here I could call it use case test as well. Basically code level tests that want to verify any dependencies that are included in a use case, but on a code level and without any other test frameworks, like, without setting up an application context or something like that, only via plain Java. And what I do, this coffee shop, this is an example that uses a dependency of order processor. And in my test scope, I actually extended for a test double coffee shop TD and an order processor test double. Why? Because these, let's have a look at the use case test, actually set up all of these mocks and verification that is required. So this order processor, let's use the other one first, coffee shop test double, sets up all of these mocking and verification, and then I have nicely readable business-like methods like verify the creation of an order, for example, that I can use in my use case test. So in a similar way, I can just say, well, basically test creation of an order, and now here you see it's really readable because it only says, well, create order, that's basically the business method, and then afterwards verify the creation of an order, and I'm now just executing it. And then all of that, well, runs fast, of course, because it's also just plain JUnit, and it is readable because, again, of these components of basically the delegation and the abstraction that we put in. So as some takeaways, and these were only a few points of a very complex topic, but most important takeaway, it is that the code quality of our tests matters. So it's not, just test code that we should not care about. It is really also important to especially use proper abstraction and delegation in our test code. And this is more important than sophisticated test frameworks. So we want to create reusable test components like these, test doubles or these coffee order system that we can reuse in many test cases and test methods and test classes. And by separating the life cycles, we gain fast feedback and really short turnaround cycles, as you've seen, because I don't want to wait for the creation of an environment each and every time. And also, as bonus points, if you can create reusable test scenarios, like I had my scenario that I fired against my Kubernetes cluster, and do them and build them up in an idempotent way so that I can rerun them again and rerun them again without tangling the test scenarios to my status of my enterprise system. Because otherwise, I always need to restart my system or something like that. So in the same way, like on a production-like setting, I can just fire up my tests against these environments. All right, and in this way, I hope it was an interesting topic. Thanks a lot for your attention. If you follow the first link here on this slide, then you will get all of the access to all of this code, so you can try it out yourself. There's also an introduction how to get started with Kubernetes and Istio if you need a cluster there and how to get one. And you see a few more links here. And we have just a little bit of time to answer some questions. So I will just read the questions I have right now in the chat. So first question, how is testing microservices different from testing classical Java EE and Jakarta EE applications? Well, I would not say it's much different if you do it in a quote unquote reasonable way, because we want to have efficient testing. Well, first of all, on a use case level for anything that can be tested efficiently in our application, and everything that is regarded with microservices, well, we just need to be sure that with microservices, we have a lot of communication usually, and then we do things like I showed you with, for example, test scenarios that we can verify locally using containers, that we can test the communication as early in our pipeline as possible, ideally on our local computer before we commit something into version control and let the CI/CD pipeline fail, so that we get that feedback faster locally. All right, and now the time is ended. I will try to follow up the other questions in the conference platform. And thanks a lot for your attention. Bye.